problem that motivated the search and rescue mission involved a missing person. The missing person is Joe. Joe needs locating and he also needs some medicine. He left from the O'Reilly's resort and is likely on the hiking track heading towards the crash site of the Stinson aircraft in the McPherson Range on the Queensland-New South Wales border.
As for the environment and location, we know roughly where Joe is likely to be as he was hiking to the crash site. The departure point is set on the north of O'Reilly Resort and our flight strategy will be focusing on this.
The aircraft's airframe is a delta wing combined with a tilt wing body, which is able to go into hover and cruise flight. It's powered by an electric engine, which uses a lithium polymer battery. The aircraft's payload consists of a video camera to observe the flight path, a still camera to scan the ground, and of course the first aid kit for Joe. To ensure a safe arrival of the first aid kit, the aircraft will land beside Joe and offer him the equipment.
This is the final flight strategy decided on by the group. The mission task provides that Joe will be in an open field, therefore all open fields represented by the colored circles will be inspected by the UAV. The onion strategy was implemented to reduce the length of flight. This is the mission design sketch. This scenario involved finding Joe at checkpoint 12. The UAV will vertically take off from O'Reilly's farm and reach a height of 120 meters. Once the UAV reaches the rainforest retreat, it will drop to an altitude of 45 meters, and once it is out of the vicinity, it will ascend to the previous height. It will complete the first inspection, return to base, replace the battery, and commence the second inspection. Once it finds Joe, it will perform vertical landing and distribute the package to Joe. Once Joe makes contact with the base, the UAV operator will send a command to the UAV to return to the base.
For the flight strategy, the UAV will operate with two routes. Both routes are designed based on the hiking track and open area. The first route is the long path which focuses on the external area as the video shown. It maintains the altitude with 100 meters, but somehow it rarely changes caused by the aerodynamics. If Joe is not found in this process, the UAV will charge at the base and operate with second route, which focuses on the internal area until Joe is found. Once we found Joe, the UAV will drop the payload around the spot.
Various tests were conducted to ensure the functionality of the systems are optimal. The main systems involved were the UAV itself, ground control station, communication links, and the payload. The operational compatibility was assessed between systems in flight. For more information on how each system was tested, see Deliverable 2.
Rescuing Outback Joe is threatened by several risk factors. For example, extreme weather conditions, fire, or cyber attacks. To prevent bad outcomes, we developed individual solutions for every risk factor. Covering the battery from impact, for example, reduces the chance of fire, while cyber attacks are levered by an uninfluenceable flight termination system. Extreme weather conditions can be avoided by early detection. Further information about risks and safety can be found in Deliverable 2.